So in this lesson I want to look at just recapping some of the things we've looked about in this section on linear relations, and just looking at kind of a few places they might crop up. So here we have a graph showing the relationship between Australian dollars and euros. A couple of things to know. I know it's a linear relation. Why? Because, well, it's a straight line graph, and all linear relations form straight line graphs. That's why they're called linear relations. Linear relations. Also, this is a linear relation that contains the origin down here. And when a linear relation contains the origin, it is what's called a direct proportion. Now, not all linear relations are direct proportions, but all direct proportions are linear relations. So if it contains the origin and it's a linear relation, then it is a direct proportion. What that means is, as one variable, increases by a certain percentage, well then the other variable will increase by the same kind of percentage. So if I double the number of Australian dollars, I will be doubling the number of euros. If I triple the number of Australian dollars, I'll be tripling the number of euros. So we have here 60, 40. Important to know what that means in the context of this graph. In the context of this graph, 60, 40, well, 60, that's my x-coordinate, and my x-coordinate are Australian dollars. 40, that's my y-coordinate. My y-coordinates are euros. So what this graph is saying is that 60 dollars, Australian dollars, is equal to 40 euros. I'm not sure that's the symbol for Australian dollars. I'm going to just assume it's the same as the symbol for American dollars, but I don't actually know if it is or not. So 60 Australian dollars is equal to 40 euros. That's what that point means. Because it's a direct proportion, that means if I double these things, 120 Australian dollars must be equal to 80 euros. Half them, 30 Australian dollars, must be equal to 20 euros. And you can see the 30, 20 point there, 30, 20. 30 Australian dollars equal to 20 euros. If I triple each of these, 90 Australian dollars must be worth 60 euros because it's a direct proportion. 90, 60. There we are there's the point 90, 60. So I can use my graph here to kind of translate dollars into euros or vice versa. The other thing maybe I want to do is come up with some kind of equation to kind of establish what's going on here. So it's a linear graph. It's of the form, we can write it in the form y equals mx plus c, slope-intercept form of the equation of a line. Note here that the y-intercept is 0, so that's my c. C is going to be 0 here, so we actually are talking about y equals mx, which is also the definition of a direct proportion. Two variables are directly proportional if one variable is a constant multiple of the other. In other words, if I divide one of the variables by the other, I always get the same constant. 90 divided by 60, 1.5. 60 divided by 40, 1.5. 30 divided by 20, 1.5. I want to find the equation of this line. Y equals m. Remember, m we said is slope. So to find the slope, well, we'll use the point that was given maybe, and the origin as our 2 points on this line. To find the slope, I just need to establish what is the rise. Here it's 40. And what is the run? Here it's 60. The slope is the rise over run. So the slope is 40 over 60, which reduces to 2/3. So y here is equal to 2/3 of x. Okay? And we can translate that, y equals 2/3 x, into the variables in question. Remember, on the y-coordinate we have the amount of money in euros. So amount of money in euros is going to equal to 2/3 times whatever my x-coordinate represents. Well, my x-coordinate represents my amount of money in Australian dollars. Okay, so the amount of money in euros is 2/3 times the amount of money in Australian dollars. And if I, change the subject of that formula, I can make the Australian dollars the subject of the formulas by tripling both sides and then halving both sides, multiplying both sides by 3 and then dividing both sides by 2, and I'll find that the amount of money in Australian dollars can be written as 3 over 2 times the amount of money in euros. And they're both useful things, and I should be able to, think about each of the different variables as the subject of the formula. So suppose I wanted to find out how many euros I would get for $3,000. No, 3,000 is not on my graph, but I did establish a formula here. The amount of money in euros will be 2/3 of the amount of money in dollars, which I'm saying is 3,000. 2/3 of 3,000. Well, 1/3 will be 1,000, so 2/3 will be 2,000. 2,000 euros is the amount of money I would get in euros for 3,000 Australian dollars. Suppose I wanted to find out how many Australian dollars I would get for, say, 500 euros. Well, I'd have 3 over 2 times 500 is the amount of money in euros. I'm using this formula here to convert from euros into dollars. Half of 500 is 250. 3 times 250 is 750 Australian dollars. So 750 Australian dollars is equal to 500 euros. 2,000 euros is equal to 3,000 Australian dollars. 90 Australian dollars, 60 euros. 60 Australian dollars, 40 euros. 30 Australian dollars, 20 euros. Etc., etc. Okay, so graphs crop up in the real world in word problems all the time. You got to be able to deal with them.